always a single number, it's always a single percentage, it's a point estimate that's going to lie within the interval. Okay? So use a more precise language over here, and be sure to mention that the true proportions, or the population proportion, you have to distinguish that from your simple statistics. Because that's what we're estimating. And as well, if we're 95% confidence, if we're asking about how many students like to make walk, it's going to be between 8% and 18%. Yeah.
What do you mean you say the true proportion, like when we state it?
So you have to say the true proportion, or the population proportion. Because if you want to say that proportion using versus students, I don't know if you're suggesting it's the sample population, it's the sample proportion or population proportion. Okay. Any other questions? All right. So another thing we can do is we can estimate or inference the relationship between two variables. We can observe some kind of relationship between two variables in our sample. But we also want to know if that same relationship holds when we generalize that into our population. So we do that is most basically we form a null hypothesis. Saying that in the past few weeks, null hypothesis basically means that there is no relationship between the two variables of your interest. There is no difference. Or alternative hypothesis basically your research statement that there is some kind of relationship going on between the IB and the DB. So suppose, again, we have this case. In comparison of partisans, those who are Republican have higher income than those who are Democrats. So let me refresh your memory. What is the independent variable in this hypothesis? You have to know this during the finals as well. What is the independent variable?
Partisanship.
Yeah, partisanship. Very well. What is the dependent variable? Income level. What is the unit of analysis? Partisanship. Right. So, remember, the IB is not Republican or Democrat. These two are the values your independent variable can take on. Your independent variable has to be precise. It's a partisanship. And your DV is not higher income as well. Higher income is just the value your dependent variable can take on. Your dependent variable should be more precise as in income level. So if we form a null hypothesis, that means that the income of the Republican and Democrat is the same. If you subtract them, it's going to be 0. And your alternative hypothesis is going to be greater than 0 because we're asserting that Republicans are richer than the Democrats. Okay? So the way we do test difference, if this difference exists, basically like this. We specify the null hypothesis, alternative hypothesis. We specify the significance level, which is normally called alpha, which is normally 0.05. Calculate appropriate test statistic, obtain p-value. This part you don't need to know because in finals we're going to provide you with those numbers. You don't need to calculate them. But the final part is the most important. This is the part that you need to remember. How do you reject a null hypothesis, or how do you don't reject a null hypothesis based on the comparison between the p-value and the significance level, which is always 0.05? If the p-value we provide you with is smaller than 0.05, which means you can reject the null hypothesis, which means you can say that there is a difference going on in the populations. Your independent variable actually influences your independent variable. Yeah?
Are we always going to be given p-value for only 0.05 for p-value?
No. The alpha is always going to be 0.05, but p-value is going to vary. It might be.
Oh yeah, like so, because I remember like in class I had asked her if I could always use like that method, and she said, well, it depends if you're given a p-value to compare it to 0.05. So like, are we going to be given p-value on the first
Yes.
one? Okay.
You don't need to calculate p-value. You don't need to do like Z statistics or T statistics things. No, I think we're just going to provide you with p-value, and all we need to know is compare which of these two numbers is greater, and you will know how to do that. Okay. So if p-value is greater than 0.05, then that means you cannot reject the null hypothesis. There's no difference going on in population. Whatever you observe, difference going on in your sample, that probably just purely due to chance. It does So here is kind of like an exercise for you. Suppose we have this hypothesis in comparison students, those with Shaw majors, they're going to be more likely to favor Lake Walk than those with School of Natural Science and Tech majors. What is the independent variable?
Students.
What major or like what?
Yeah, type of school, major, whatever. What is the dependent variable?
Favoring like walk.
Your opinions toward Lake Walk. Okay. Remember, it's not favoring Lake Walk because favor is a value you can take, and your independent analysis is the students. So suppose something like this. We want to form no hypothesis, it will be something probably like that. Number of people, percentage of people, proportion of people in Shaw means that's good, minus that, it's going to be zero because there's no difference between schools, and our alternative hypothesis is that there is a difference between your school and her. So we can test that either using testing the means, testing the proportions, or we can use a regression to test that. It depends on how your variable is measured. So suppose like testing the difference of means. If we measure your opinion toward Lake Walk in some kind of average rating from 1 to 10, 10 is the you like most, 1 is you dislike most. In your quiz, you're going to see something like this, a table. For those Shaw majors, their average rating from 1 to 10 is 7.6. For the School of Natural Science majors, your average rating is 6.7. And the difference is 0.9. Now, this is the difference we observe in the sample. We want to know if this difference still exists in the population, or this difference doesn't exist. This difference in the populations is essentially equals to 0. That means no hypothesis. We can test that using the p-value or the 95% confidence interval, which is the value we're going to provide you with. So in this case, can we reject the null hypothesis?
Yeah.
See. Can we?
Yes, but barely.
Right. So if you remember, the alpha is always going to be 0.05. And in the question, we're going to provide you with alpha as well. So all you need to do is find a p-value, which is over here at 0.032. Which is less than 0.05, that means you can reject the null hypothesis, and you can say that those with Shaw major actually likes Lake Walk more than those with School of Natural Science major in your population. Okay? Suppose we change the questions now, we measure that in terms of percentage of students favored. This is a test of difference of proportions. It's the same as well. Numbers are different, like in Shaw major, maybe like 25% like it. In natural science, 23% like it. The difference is going to be 2%. Again, we're going to provide you with p-value and 95% confidence interval as well. So in this question, can we reject the null hypothesis?
No.
Can we?
No.
No, right? Because 0.877 is definitely greater than 0.05. So we cannot reject the null hypothesis. We can only claim that, well, there's nothing going on. Your type of school, your major, it does not influence your opinions toward that restaurant. Okay, does that make sense? So in all the questions, basically what you need to do is identify a p-value. And then identify whether this p-value is greater or less than your level of significance. And then provide me with some kind of claim. Do we reject the null hypothesis or do we not? If we reject the null hypothesis, what does it mean? If we cannot reject the null hypothesis, what does that mean? Provide me with those information, then that should be fine. Okay? Any other questions? So last part is we call it regression. So it's basically the same thing. Regression is kind of like line. You're predicting your dependent variable using your independent variable. In this case, we're suggesting that the average rating of the Lake Walk is going to be influenced by whether you are a Shaw major or you are a School of Natural Science major. And the thing we're testing here is not a difference. It's instead this coefficient over here. So if this relationship holds true, that means being a Shaw major student is going to increase 1.06 average rating the lake wall. Now, that might be something we observe in our sample, or does it happen to catch onto our population as well? If our null hypothesis is correct, then that means this 1.06 is essentially 0 in your population. There's no difference going on whether you are a Shaw major or you are a simple natural science major.
And you would reject this opinion.
Yes. So you're going to see the table like this. This thing doesn't mean the constant is your intercept. You don't need to worry about that. You find the independent variable of interest. You're going to see a lot of statistics over here. None of you, most of these doesn't matter. What matters is over here. This p greater than absolute value of t. This is a p-value, okay? So when you're reading this table, find your independent variable. These doesn't matter. Find a p-value. If p-value is over here, then that means it's 0.000. Can we reject null hypothesis? We can, right? Because it's less than 0.05. So it's the same. Doesn't matter if it's a difference of means, difference in proportions, or it's a regression table. Always look for the p-value and compare that with 0.05. If it's less, then that means there's no difference. Your independent variable does not influence your dependent variable of it. If it's less, that means there is a difference. Your independent variable influences your dependent variable. If your p-value is greater than that, that means there's no difference. Your null hypothesis is probably correct. Question? Okay. So the last one we're going to talk about is how to draw a time series graph. It's actually very similar to how you draw a bar chart. If you remember during your midterm, we're going to provide you with a table, some statistics, and some time variable. In this case, a month. Okay, so in your in final map, right, it will be year or like days, doesn't matter. It will be a time variable. So what you need to do is two axes. The axis is going to be your time variable. In this case, it's August all the way to December. And the y-axis is going to be percentage. So okay, you label that over here. And you'll link those dots together. This is the time series graph. Okay, it's as easy as this. Basically, specify the time variable all the way over here. If we provide you 10 years from like 2010 to 2020, whatever, then you have to specify 20 variables over here, and then attach the percentage or simple statistics. It might be a proportion, it might be a mean, or income age, something like that. So specify over here, label them, and then you draw the dots, and you connect them all together. That's how to draw a time series graph. Question?
So it's like a line chart, basically?
Yes. So it's actually the same as if you draw this as a bar chart. But in this case, we don't want you to draw a bar chart. We just want you to draw like a time series graph, just points linked together. Any other questions? All right, that's it. That's the end.